Okay, so our discussion for today is the part one of the acid-base equilibrium and solubility equilibrium chapter. Okay, so this is a lengthy topic. Okay, this is a lengthy chapter. So, ito yung ating coverage for this chapter. Ang dami na. So first, we will define acids and bases. There are lots of definitions whether a compound is an acid or a base. No? So titignan natin sila isa-isa later. No? Then we will discuss the acid-base property of water. Okay, its auto-ionization into hydronium ions and hydroxide ions. And then we will discuss the strengths of acids and bases. No? Some acids are strong, some acids are weak. Okay, the reason why they are strong and weak will be discussed on this chapter. Then, after that, we will proceed with the acid-base equilibrium constants and the acid-base equilibrium calculation and techniques. Followed by that is the diprotic and triprotic acid system and buffer solutions. Then lastly, we will end this chapter by discussing solubility equilibria for precipitates, no, or for sparingly soluble salts and the common ion effect and its solubility. Okay. So let's go sa first part, no. So let's define acids and bases, no. Before we define them, let's try to see their characteristics first, no. So ano yung alam natin? Paano natin malalaman kapag may acid yung isang bagay or pag may base? Okay. So when it comes to taste, yung mga acid compounds, they taste sour. Okay. So ano yung example ng mga maasim? Yung let's say mga lemon, okay? Mga citrus fruits, no? Yung suka. Okay. So sila ay maasim. Bakit? Because sa suka, it contains an acid called the acetic acid. For citrus, they contain what's called an citric acid, no? And sometimes they also contain ascorbic acid, no? So lahat ng acid maasim sa taste, okay? And then when your acid reacts to metals, no, they produce hydrogen gas, okay? So that was given to us last year, no? Last semester pala, dun sa video na ako yung tao doon. Sa laboratory din yun, no? Sa acid-base reaction. Pinakita ko doon that when you react acid with metals, it form bubbles, no? For that particular video, ang ginawa ko doon is may hydrochloric solution ako. Then I dropped zinc metal. And what happened sa zinc metal is that nag-react siya with HCl to produce zinc chloride and hydrogen gas na. Hopefully naalala nyo pa yung video na yan. And then another one is that acid reacts with carbonates to produce carbon dioxide. Andun din yun sa video na yun. So ginawa ko doon, I have hydrochloric acid. I reacted it with sodium carbonate. Then what happened? Nagbubbles yung reaction. No? Okay. So why? Because carbonates are unstable in acidic media. That's why they produce carbon dioxide. Okay? So yun. So yan yung characteristic ng acid natin. Maasim sila. They produce hydrogen gas when reacted with metals, and then when reacted with carbonates, they produce carbon dioxide gas. One example here is the baking soda. Yung baking soda, lagyan mo ng suka, bubula yan. Because baking soda has sodium bicarbonate, and then yung suka, it has acetic acid. No? So acid, carbonate, or bicarbonate, it will produce carbon dioxide gas. Okay? So for bases naman, bases have bitter taste. No? For example, yung mga ampalaya, di ba? Bitter yung taste nila because may mga base compounds doon, especially yung mga plant-derived molecules doon. Yung mga tawag doon. Basta yung mga organic na base doon. Kalimutan ko yung tawag sa group na yun. Pero anyway, so yun, bitter yung taste nila. For example, ampalaya and then yung other gulay. Okay? And also, they feel slippery. For example, yung soap, no? Yung sabon, madulas. Bakit? Kasi may base doon. Okay? So, many soaps contain bases. Okay? So, paano ba nabubuo yung soap natin? Pinagawa ko 'to sa tutorial class ko last sem, okay. So ginawa namin, we produced soap 'no, by mixing oil and sodium hydroxide or potassium hydroxide. So kapag pinaghalo mo yung dalawang yon, sabon yung magagawa mo. Yun yung ginagawa, in the old times 'no, mga before Christ era pa. Kaya until now, gano'n pa rin yung concept ng paggawa ng sabon. You just mix the fatty acid sa mantika with the sodium hydroxide and it will produce soap molecules. Okay? So, yan yung characteristic ng acid and base natin. Okay? So, kapag acid, maasim. Pag base, bitter. Okay? So, ganun. Pero ngayon, paano natin made-define kung ang isang molecule ay acid or base? Siyempre, in our case sa ngayon, hindi mo naman matitikman lahat ng chemicals. Una, kasi delikado. So, paano mo malalaman kung yan ay acid or base, no? You can tell by its molecular formula, okay? Or by its reaction, okay? So, pwede natin makita yung ating molecule if yan ay acidic or basic by just looking at the molecular formula and by looking at what it does in a chemical reaction, okay? So, there are three definitions that is primarily used in chemistry. We have the Arrhenius definition. This is the oldest definition of acids and bases. Then it was followed by the Bronsted-Lowry definition and the Lewis definition. Okay. So actually, sobrang dami ng definition yan. We have the hard acid, soft base, ano, definition and other stuff. No? Pero for things to be simpler, itong tatlo lang di-discuss natin, okay? So, sandamukal yan definitions ng acids and base. Pero for now, ito lang gagawin natin. Okay. So, let's look at the let's look at the first definition of an acid and base, okay? So, let's talk about Arrhenius definition. So, according to Arrhenius, acid is acid is a substance that increases the concentration of hydronium ion when it's dissociate or proton when it dissociates. And bases are substances that increase the concentration of hydroxide when it dissociates. No? So, ibig sabihin, according to Arrhenius, ang acid daw, it has a proton na na cation. Okay, so when you have an ionic compound wherein the cation is proton or H plus hydronium ion, it is an acid, no? Basta H yung kanyang cation. Okay, kasi what happens to an ionic compound? It dissociates into its ions, di ba? From ionic compound, nagiging cation anion siya. Okay, so according to Arrhenius, kapag cation yung H plus, acid yon because after it dissociates, it will increase the H plus concentration in the solution. Kapag base naman, sabi ni Arrhenius, yung anion mo ay OH, hydroxide. Okay? So, yan. So, here are some few examples lang. Mga basic examples lang. We have Arrhenius acid, hydrochloric acid. Our cation here is H plus. So, we have HCl. When it dissociates in water, it produces H plus and Cl minus. Okay. So, since this molecule produced H plus, Arrhenius acid ditawag dyan, or just simply acid. Ito naman, sodium hydroxide is an Arrhenius base. Bakit? Kasi it contains an anion, OH minus, okay, hydroxide. So when sodium hydroxide dissociates in water, it produces sodium ion and hydroxide anion, okay. So since it produces OH minus, yan ay Arrhenius base, okay. So again, to make things simple, pag Arrhenius definition, sabi niya, ang Arrhenius acid, it will produce H plus because the cation is H plus. Okay? And kapag Arrhenius base, it produces OH minus. Okay? Kasi it contains the anion OH minus. Okay? So, yun lang. So, ganun lang siya ka-simple. And ito din yung definition na ginamit natin last semester. Okay? So, remember yung acid-base balancing natin. So, Arrhenius definition yung ginamit natin doon wherein yung acid may H Yung base may OH, no? Okay. So let's look at the next definition kay Bronsted-Lowry definition. So dalawang tao yan, si Bronsted and si Lowry. They describe the acid and base as either proton donors for acid and proton acceptor for base. Okay? So yan. So paano? Okay, ganito lang. Just look at the equation we have here. So we have HCl plus H2O. It is in equilibrium to produce H3O plus and Cl minus. Okay. So, sino yung Bronsted acid? Sino yung Bronsted base? Okay. So, again, balikan natin definition. When we say acid, Bronsted acid base, Bronsted acid, sabi dyan, it donates protons. So, ibig sabihin, sa molecular formula, after the reaction, mababawasan siya ng H. Okay? Kasi nag-donate siya ng H yun, no? Okay? So, parang kunwari, nag-donate tayo ng money to someone. Kapag tayo nawalan ng money, ibig sabihin, ikaw yung acid. Okay? So, ganun din dito. So, just look at the equation and check which molecule lost a proton. Kung sino yung molecule na nawalan ng proton, siya yung acid. Okay? Then, tignan mo naman kung sino yung tumanggap ng proton na yon, because proton acceptors are called the Bronsted-Lowry base. Okay? So, gagawin natin dito, we will look at the equation and then we can tell kung sino yung kung sino yung um, acid and base doon according to Bronsted-Lowry definition. So, let's look at these examples. By the way, may typo. Nakalimutan ko yung plus symbol sa gitna. Okay, so anyway, so let's look at this one, HCl plus water in equilibrium to produce hydronium ion and chloride ions. Okay, so sa reactant, tignan mo, sino yung nabawasan ng H pagdating sa product? Okay, so by just looking, HCl, ito yung nawalan ng H. Kasi pagdating sa product, Cl minus na lang siya. Okay, so this molecule lost hydronium ion. So that means it is the Bronsted-Lowry acid. Okay, so Bronsted-Lowry acid yan because it lost a proton pagdating sa product side. Okay, nawalan siya ng H. So Bronsted-Lowry acid yan. That means water is the Bronsted-Lowry base. Okay? So, paano siya naging Bronsted-Lowry base? Because look at the reaction. It gained a proton. So, nadagdagan siya ng H pagdating sa product side. Okay? So, from water, it became hydronium ion. Okay? So, ganun lang kapag Bronsted-Lowry definition. Just look kung sinong molecule yung madadagdagan or mababawasan ng H. Pag yan ay nabawasan ng H, that's acid. Pag yan ay nadagdagan ng H, that's base. Okay? So, for example, we have HCl. Pagdating sa product side, it turned into Cl minus na lang. So, that means yan ay Bronsted-Lowry acid. How about ammonia? Yung ammonia, it became ammonium ion, NH4. So, nadagdagan siya ng H. So, ibig sabihin yan ay Bronsted-Lowry base. Okay? So, ganun lang. Okay? So, compare natin yan with Arrhenius definition. Pag Arrhenius definition, sabi niya, ang acid may H+, ang base may OH-. Pero look na, tignan nyo sa Bronsted-Lowry definition. Yung ating bases, they do not contain the OH-. No? Hindi obvious yung OH- nila. Okay, but since they accepted the proton, then we can define them as Bronsted-Lowry bases. Okay? So, yun. So, yun lang yung subtle difference nilang dalawa. Si Arrhenius sabi, basta may OH base yun. Totoo naman yun. Pero, pagdating sa mga molecules na hindi obvious yung OH, for example, NH3, you have to look kung siya ba ay nadagdagan ng proton or hindi sa reaction. Pag siya ay nadagdagan ng proton, so ibig sabihin nun, yan ay base. Okay? So, another example would be H2O. It didn't produce OH- naman, pero it is the base. Okay? So, ganun. Kasi nadagdagan siya ng proton. Okay. So, yung Arrhenius definition, this will not work for these examples kasi wala tayong OH minus na na-produce. Instead, we produced a molecule with additional hydrogen sa kanya. Okay. For example, H3O plus and NH4 plus. Okay. So, yan. Um, let's look at this one again. So, we have ammonia reacting with water, producing ammonium ion and hydroxide ion. Okay. So, define natin, sino dito yung Bronsted-Lowry acid and base. No? So, kung titignan nyo, si ammonia, ano nangyari kay ammonia? Pagdating sa product side, nadagdagan siya ng H+. So, tawag kay ammonia ay Bronsted-Lowry base. Kasi nadagdagan siya ng H+. No? Tumaas yung proton number niya. Si water naman, on the other hand, it became hydroxide ion na lang. So, ano nangyari kay water? Nabawasan siya ng H. Okay? So, ibig sabihin, since nabawasan siya ng H, tawag sa kanya ay Bronsted-Lowry acid. Okay? So, mapapansin nyo, yung ating Bronsted-Lowry definition, it only applies to the reactants, no? So, ito nabawasan ng H, so siya ay acid. Ito, nadagdagan to ng H pagdating sa product side, siya ay base. Okay, so ito yung base, ito yung acid, pero ano yung tawag natin sa products? Okay. So ano yung pwede nating tawag sa kanila? Okay. So may tawag sa kanila. Tawag doon ay conjugate acid and conjugate base. Okay. So ano yung conjugate acid? If you have a Bronsted-Lowry base, it will produce a conjugate acid. Okay. Okay. So ganun lang. So kapag may base ka, it will produce a conjugate acid. Okay. Counterpart, conjugate, meaning nun, kabaliktaran. Okay? So, yan. So, if you have a Bronsted-Lowry base, it will produce a conjugate acid. Okay? So, ganun. So, itong NH3, ito yung base according to the reaction. Itong NH4, yun na-produce ng NH3 as it accepts the electron, as it accepts the proton, it is now called the conjugate acid. About itong, water. So, since we call this the Bronsted-Lowry acid, pagdating sa product side, ang tawag natin sa OH ay conjugate base. Okay? So, yan. Kaya meron tayong tinatawag na conjugate acid-base pair. Okay? So, it tells us that the base, ang kapartner niya ay conjugate acid, and ang Bronsted-Lowry acid, ang kapartner niya ay conjugate base. Okay? Now, let's look at some more examples here. We have acetic acid and methylamine. It will produce acetate ion and methylammonium ion. So, tignan natin. Sino yung acid, sino yung base, sino yung conjugate acid, sino yung conjugate base. Okay. So, acetic acid, look at what happened. It lost a proton pagdating sa product side. So, obviously, since it lost the proton, we will call it the Bronsted-Lowry acid. Okay, so Bronsted-Lowry acid yung acetic acid. Ano tawag sa acetate ion? Siya ay conjugate base. Okay, so again, kapag acid yan sa reactant, pagdating sa product side, we will now call it the conjugate base. Okay, so ano yung difference ng acid and conjugate base? Nabawasan lang ng H. Okay, so tignan mo, isang hydrogen lang difference nila. From acid to conjugate base, babaklasan mo lang siya ng isang H. Okay? So, yan. Yung OH naging O minus na lang. Okay? So, this is the Bronsted-Lowry acid. It lost the proton. Once it lost the proton, tawag sa kanya ay conjugate base. Okay, how about this one? Methylamine. So, since methylamine, tignan mo yung molecule niya, nadagdagan siya ng H pagdating sa product side. So that means methylamine is the Bronsted-Lowry base. So, siya si base. Pagdating sa product side, ang tawag sa kanya? Ang tawag sa kanya ay conjugate acid. Okay? So, ganun lang. So, that's how we check kung sino yung conjugate acid-base pair natin. Okay? So, si acid, it will produce conjugate base. Si base, it will produce conjugate acid. Ano yung difference nila? Yung dami ng H, no? So, nagbabago lang yung H nila by 1. Pwedeng madagdagan siya ng isang H, pwedeng mabawasan siya ng isang H. Okay? So, ganun lang. Ito pa. Look at this example. I want you to tell me kung sino yung bronzed lauric acid or base and sino yung conjugate acid pati sino yung conjugate base. So, we have acetic acid and we have acetate ion here. Sino yung acid? Anyone? You can use your microphone. Sino yung acid dito? Sino yung nawalan ng H? Okay? So, tignan mo lang. Sino yung nawalan ng H? Siya yung acid. Syempre, obvious na yan, no? Obvious na, nasa name na mismo eh, acetic acid. So, ibig sabihin siya yung acid. Okay? So, ganun lang. So, yung acetic acid, pagdating sa product side, nawalan siya ng H. So, this is the bronzed lauric acid. Okay? So, since ito ay bronzed lauric acid, ano tawag natin sa acetate ion? Ang tawag sa kanya ay conjugate base. So, ganun lang. So, if you have an acid, pagdating sa product side, once it lost the proton, tawag sa kanya ay conjugate base. Okay, how about water? What happened sa water? Ano yung water natin? Is this an acid or a base? Syempre, since yung kabilang molecule ay acid, dapat base siya. Okay, so we will call water as the bronzed lauric base. So, ano tawag sa H3O+? Ito yung conjugate acid. Okay? So, ganun lang. So, yan lang. Another example. Ay, hindi. Nabigay na pala to kanina. Nabigay na to sa drawing. Okay, so alam nyo na dito that ammonia, this is the base because pagdating sa product side, nadagdagan siya ng H. So, we will call this product the conjugate acid. Yung water naman, this is the acid. Kasi pagdating sa product side, it lost a proton. So, ito ang tawag sa kanya ay conjugate base. Okay? So, ganun lang. And then, the last definition for acid-base is the Lewis definition. So, ano yung kwento naman ni Lewis? No? So, according to Lewis acid is a substance that can accept a pair of electrons. And Lewis base is a substance that can donate the pair of electrons. Okay. So, paano yun? Okay, ganito lang. What happens when your molecule donates pair of electrons? So, ano nangyayari sa molecule kapag nag-donate siya ng electron? It will form chemical bonds, no? Kasi, remember, there are 2 electrons needed to create a bond, na. So, ibig sabihin dito, kapag yung molecule, siya yung nag-donate ng electron para magkaroon ng bond, siya yung base. And kung sino yung molecule na tatanggap ng pair of electrons na yon, ang tawag sa kanya ay acid. So, let's look at some examples here. We have H and OH, no? So, looking at this, yung ating base, may 3 lone pair yan. Pagdating sa product side, 2 lone pair na lang meron siya. Since nabawasan siya ng lone pair, that means it donated 2 electrons kay hydrogen para magkaroon ng chemical bond. Okay? So, ganun lang. Just count the lone pairs. Ganun lang ginagawa ko kasi. Bibilangin ko lang lone pairs dito, 3. Pagdating sa right side, 2. So, ibig sabihin, siya yung base kasi it donated the lone pair. So, nag-donate siya ng pair of electrons. Kanino niya dinonate? Dun sa dinugtungan niya, si hydrogen. So, acid is the H plus is the acid because it accepted the 2-electron pair from the base. Okay. So, look at this pa. So, we have the ammonia. May isang lone pair yan. Pagdating sa product side, wala na siyang lone pair. So, ibig sabihin, nag-donate siya ng lone pair. Kanino? Kay H. Okay, so since ammonia donated the lone pair to hydrogen, siya yung base. And since yung acid, yung H+, tinanggap niya yung lone pair, siya yung base. Siya yung acid, no? So, ganun lang yung definition ni Lewis, no? Kung sino yung nabawasan ng lone pair, siya yung base. Kung sino yung nagkaroon ng chemical bond, siya yung acid. Okay? So, here's another example. Tignan nyo uli yung ammonia, isa yung lone pair niya. Pagdating sa product side, wala na siyang lone pair. So, ibig sabihin nun, dinonate niya yung lone pair to create the chemical bond. Okay? So, yung ammonia ang base natin. That's the Lewis base. And yung BF3, boron trifluoride, since siya ay nadagdagan ng chemical bond, siya ay acid, Lewis acid. Okay? So again, paano nyo madali makikita kung sino yung Lewis acid, sino yung Lewis base? Just look kung sino yung nabawasan ng lone pair. Kung sino yung mababawasan ng lone pair, siya yung Lewis base. Kung sino yung madadagdagan ng chemical bond, siya yung Lewis acid. Okay? Tignan nyo yung boron. 3 yung bonds niya. Pagdating dito, 4 na. So, ibig sabihin, siya yung Lewis acid. Okay? So, ganun lang yung definition niya. Okay? So, yun lang. So, those are the 3 definitions of acids and bases. Again, so let's take another look before we proceed. Sabi ni Arrhenius, ang acid may H plus na pinoproduce. Ang base may OH minus na pinoproduce. Okay? So, ganun lang. Pag may H plus na produce, acid, according to Arrhenius. And pag may OH na produce, Arrhenius base. Okay? Sabi naman ni Bronsted Lowry, ang acid, they are proton donors. No? So, katulad lang din ng kay Arrhenius. No? So, yung acids, they donate protons. However, sabi ni Bronsted, yung base daw, it accepts the proton. Okay? Siya yung tumatanggap ng H instead na mag-release ng OH. Okay? So, ayan. So, tignan natin yung mga examples natin kanina. So, from HCl, naging Cl minus. So, since nawalan niya ng proton, yan ay acid. Yung H2O, naging H3O. Since siya ay nadagdagan ng H+, siya yung base. Okay? Kung sino yung nadagdagan ng H, siya yung base. Kung sino yung nabawasan ng H, siya yung acid. Okay? Ang tawag natin sa mga napoproduce nila ay conjugate acid and conjugate base. No? So, ang ating base, it produces conjugate acid, and yung ating acid, it produces conjugate base. Ano yung difference ng acid and the conjugate base? Mababawasan siya ng isang H. Okay, so tignan nyo, from H2O, naging OH na lang. So, nabawasan siya ng isang H. So, yun. Yun lang yung difference nila. Yung acid and yung conjugate base, mababawasan lang ng isang H. Pero yung base and yung conjugate acid, ano yung difference nila? Isang H na nadagdag. So, yung base mo, pag yan ay naging conjugate acid, madadagdagan ng H yan. Okay? So, yun. So, our acid will produce conjugate base. Our base will produce conjugate acids. And according kay Lewis naman, bases are molecules that donates electron pair. So, yung lone pair, idodonate nila sa other atom. Yung atom na tatanggap ng lone pair ng base ay tinatawag nating acid. Okay? So, ano yung shortcut ko dito? Pag base, siya yung mababawasan ng lone pair. Just look at the molecule. Sino yung nabawasan ng lone pair? For example, yung una, we have the hydroxide anion. It has 3 lone pairs. Pagdating sa product side, 2 lone pairs na lang siya. So, ibig sabihin, siya yung base kasi siya yung nag-donate ng lone pair. Tapos, paano mo malalaman kapag yan ay acid? Kapag siya ay nadagdagan ng chemical bond. So, looking at H, wala siyang chemical bond. Pagdating sa right side, meron na siya. Okay. Bakit nagkaroon ng chemical bond? Because it accepted the lone pair of the base. No? So, when lone pairs are donated, it produces chemical bonds. No? So, ganun. Okay. So, and ito yung isa pang example, yung ammonia, may isa siyang lone pair. Pagdating sa product side, wala na. So, ibig sabihin, siya yung base. BF3, may tatlong chemical bonds yan. Pagdating sa product side, apat na yung chemical bonds niya. So, ibig sabihin, siya yung acid. Okay? So, ganun lang. Okay. So, ngayon, let's focus sa water. Tingin tayo sa water. So, water undergoes self-ionization called autoprotolysis. No? That means water can act both as an acid and as a base. Tignan niyo yung mga examples natin kanina. So, look, yung role ni water, iba-iba. Okay? So, for example, sa unang reaction natin, water is a base. Okay? Base siya dyan. Pero pagdating sa susunod natin example, ang water ay acid. So, that means water has this characteristic of being acid and base at the same time. Okay? So, may characteristic siya na maging acid and base at the same time na. Depende sa pangangailangan. So, that means the molecule is versatile. Okay? So, suppose we have two water molecules. Okay? So, kunwari ito, nadagdagan siya ng H+. So, this water is acid. However, at the same time, this water, it produces the OH minus. So, ito yung, siya yung magiging base na. So, ganun. So, di ba ang weird, no? Kasi we have the same molecule, pero dalawa yung characteristic niya. Pwede siyang acid, pwede siyang base. Okay? So, yun yung special characteristic ni water, no? So, water produces H plus and OH minus at the same time so that it is called the, acid-base property of water, no? So, ibig sabihin ng acid, ang water natin, it is acid and base at the same time. Okay? Okay, kasi they produce H plus and OH minus at the same time. Okay? So, yan. If we get the equilibrium constant, ito, hopefully familiar na kayo. If we get the equilibrium constant of this equilibrium equation, we will write K equals H plus times the OH minus. Again, in writing the equilibrium constant, that is the concentration of your product divided by the concentration of your reactant. Okay? If your species are liquid and solid, you must not write them in the equilibrium constant. Okay? So kapag yan ay naka-liquid or solid, hindi mo siya isusulat sa K. Okay? So since yung ating reactant siya ay liquid, hindi natin siya isusulat dito. So we will just write 1. How about the product? So we have the H plus and the OH minus. So we can write that as the product of the H plus concentration times the OH minus concentration. Or just simply this one. Okay? So if you get the equilibrium constant of the autoprotolysis of water, Kc can be written as the concentration of H plus times the concentration of OH minus. Since this equilibrium is special, okay, so special equilibrium to, bakit? Nag-e-exist lang siya sa water. No? So since this equilibrium system is special to water only, we will call it the Kw, or the ion product constant of water. Okay? So yan. So Kw tawag natin sa kanya. Kasi special to kay water. Okay? So yan. So itong equation na to, that is the Kw. That is special to water only. At 25 degrees Celsius, Kw is equal to 1 times 10 raised to negative 14. Okay? So yan. Actually, from this one, dito nag-umpisa yung pH scale, no? Mamaya, baka madaanan natin ngayon. Okay? So yan. So, again, At 25 degrees Celsius, the ion product of water is 1 times 10 raised to negative 14. So, depending on the concentration, wait lang. Lumabas si Mingming. So, depending on the concentration of your H plus and your OH minus, ano? So, depending on the concentration of your H plus and your OH minus, a solution can be characterized as acidic or basic. Okay? So, if H plus and OH minus concentrations are equal, then that means it is neutral. Okay? So, ibig sabihin ng pH equal to 7. If ang inyong hydronium ion is greater than the hydroxide ion, then your solution is acidic. Kasi sabi natin, acidic yan kapag maraming H+, no? Yun yung sabi ni Arrhenius kanina. And kapag yung solution mo ay basic, that means the OH concentration is greater than the H+ concentration. Kasi yun din yung sabi ni Arrhenius kanina, no? That for basic solutions, maraming OH compared to H+. Okay? So, also, our pKW, our KW, or the ion product of water, it changes over different temperature scales, no? So, at 25 degrees Celsius, that's equal to 1 times 10 raised to negative 14. However, at different temperatures, KW changes. Bakit? Kasi katulad nga ng sabi ko sa chapter 1, ang sabi ko doon, that water density changes at different temperature. So, since the density changes, the molarity changes. The concentration of H plus and the OH changes as well. As a result, nagbabago yung ating KW. Nagbabago yung ating equilibrium constant. Okay? So, ganun. Let's try to answer some calculation problems. Basic lang muna tayo. What is the concentration of OH minus ions in a HCl solution whose hydrogen ion concentration is 1.3 molar? Okay? Again, ano daw kaya yung concentration ng OH kapag ang H concentration mo ay 1.3 molar? This can be answered by the ion product of water, or the KW. Okay. Remember that KW is equal to the concentration of H plus times the concentration of OH minus. Diba? Pinagmumultiply yan to get the KW. And what's the KW? KW is 1 times 10 raised to negative 14 at 25 degrees Celsius. So since we are asked to solve for the concentration of OH, then we derive the equation for OH using the equation given above. No? So we can solve for OH by dividing KW by H plus. Okay? So ginawa ko, dinivide ko both sides by H plus, so I will get the equation for OH minus lang. Okay. So that means in order for us to solve for the concentration of OH, we divide KW with H plus. And then we can now plug in the numbers. Plug in mo yung number. By the way, kapag ganitong equations involving equilibrium constant, hindi ko nilalagay yung unit during calculation. Kasi the units will never cancel out eh. Okay. So, sa dulo mo na lang ilagay. Okay. So, yan. So, yung KW mo, that's 1 times 10 raised to negative 14. Yung H plus mo, ano yung concentration ng H plus? Sabi sa problem, 1.3 molar. Okay. So, let's divide them. So, we get OH minus equal to, solve natin. Okay. So, the hydroxide concentration is 7.69 times 10 raised to negative 15. Okay. So, what can we tell from this given? So, masasabi natin that the concentration of H plus is greater than the concentration of OH minus. Bakit? Ano yung concentration ng H plus? 1.3. Ano yung concentration ng OH minus? Times 10 raised to negative 15. So since H plus is greater in concentration than OH minus, then we can tell that this solution is acidic. No, acidic solution siya. Because the concentration of H plus is greater than the concentration of OH minus. If yan ay kabaliktaran, yung OH mas marami kaysa sa H plus, then tawag dyan ay basic solution. And kapag yung dalawa ay equal, that's a neutral solution. Okay? So, ganun lang. Other than the concentration of H plus and OH, we can also tell the acidity or the basicity of a solution by determining its pH. Remember that pH is the negative logarithm of the concentration of H plus. Okay. So, ganito yan. 'Di ba sabi natin, if H plus is equal to OH, yan ay neutral. Okay? In terms of pH, no, kapag equal silang dalawa, the concentration of H plus is 1 times 10 raised to negative 7. Pag itong 1 times 10 raised to negative 7, plinag in mo yan dito, you will get a pH value equal to 7. Ito question, sir, paano naging 1 times 10 raised to negative 7 yan kapag neutral yan? Paano naging ganon? Okay. So, let me give you the calculation. Paano natin nakuha yung 1 times 10 raised to negative 7? Okay. Di ba, remember, Kw equals H plus and OH minus. If H plus and OH minus are equal, then we can represent them with one variable. Sabihin natin, if H plus is equal to X and H plus is equal to OH, then OH is also equal to X, no? Mathematically speaking. So we can say Kw is equal to X. That's the concentration of H plus, which is unknown. And also X for the concentration of OH, which is unknown. Okay. So we use the same variable kasi equal lang naman sila. So we get Kw equals X squared. So to solve for the concentration of X, that's the square root of Kw. So getting the square root of this number, we will get 1 times 10 raised to negative 7. And this is equal to the concentration of H plus and the concentration of OH if the molecule, if the solution is neutral. Okay. So yun yung reason bakit 1 times 10 raised to negative 7 yun. So we just derived. Bakit kasi naging ganon? Equal lang yung concentration ng H plus and OH. Solving for X, we get this now. Okay. So that means for neutral solution, the pH is 7. So pag pilinag-in mo yan dito sa equation na to, makuha mo exactly 7. However, when our H plus ion is greater than the OH, acidic na yung solution. So kapag plinag-in mo itong concentration ng H plus greater than this concentration, makakuha ka ng pH less than that. Okay? So pH will be less than 7 if the concentration of your H plus is greater. And kapag ang inyong solution ay mas maraming base, the pH will be greater than 7. Okay? So ganun na ha. Take note na nagkakabaliktad yung symbol. So dito kapag maraming H+, mababa yung pH. Bakit naging ganun, sir? Kasi may negative sign yung pH. O, ibig sabihin, opposite talaga sila. Kapag tumataas yung concentration ng H+, bumababa yung pH because of the negative sign. Okay? Bumabaliktad yung trend dahil sa negative sign. So kapag tumataas yung H+ concentration, mababa yung pH. Kapag mababa yung H+ concentration, mataas ang pH. No? Okay? So take note, kabaliktad sila ng trend because of the negative sign. Baka kasi isipin nyo, pag mataas yung pH, mataas concentration ng H. No. Hindi ganun. Kasi the equation tells us the otherwise. No? opposite sila ng trend. Okay, so here are some of the pH values for some of the fluids that we consume. For example, lemon juice, it has a pH equal to 2.4. No? Vinegar, 3.0. Yung ating urine, sometimes it is acidic, no? Especially kapag ikaw ay may underlying disease. No? Acidic yung iyong ihi. No? So especially kapag kayo ay mayroong mga kidney stones. No? So acidic yung pH natin. Okay, and then ito yung ibang example ng mga basic compound. We have the tears. Ang tear ay medyo basic. No? So, ang blood, medyo basic din siya, slightly. We have the milk of magnesia. Yan ay magnesium hydroxide. And then the household ammonia, okay, which is 11.5. Okay? So, ano lang mapapansin natin dito? That for acidic compounds, the pH is less than 7. Okay? Because the concentration of H plus is greater than 1 times 10 raised to negative 7. And kapag ang pH mo ay greater than 7, you have a basic solution. In terms of concentration ng H plus, it is less than 1. It is less than 1 times 10 raised to negative 7. Okay? So, yun. Don't confuse yourselves with the opposing signs, ha? Bakit sila naging opposite symbols? Kasi may negative sign sa equation ng pH. So, pag tumataas yung H+, bababa yung pH. Pag bumababa yung H+, tumataas yung pH. Okay? So, ganun lang. Other important relationships are the following. Okay? So, we have the pOH, no? So, that is the power of hydroxide, no? Ang pH, that's the power of hydrogen. Pag pOH, that's the power of hydroxide. And that is equal to the negative logarithm of the concentration of OH minus. Okay? So, paano natin nakuha yung idea that pH and pOH, pag pinagsama sila, equal to 14? We use the ion product of water. Remember that Kw is equal to the concentration of H plus times the concentration of OH minus. If you get the negative logarithm of the two values, etong product na to, pag kinuha mo yung logarithm niyan, nag-i-split sila into 2. Okay? So again, yung product, kapag kinuha yung logarithm, it splits into 2. Okay? So naghihiwalay sila sa dalawa. So you have the negative log of H plus and the negative log of OH minus. So we have negative log H plus minus log OH minus. Pag kinuha mo yung log ng dalawang sides, no? Okay? Pag kinuha mo yung negative log ng dalawang sides. However, ito naman, since this is numerical value, kapag kinuha mo yung negative log niyan, yung exponent bumababa lang. Okay? So nagiging 14 lang siya. Yung negative sign, it cancels out with the negative sign sa harap ng logarithm. Okay? So yun. So yung 14 na exponent, bababa siya. So we have 14.0. So what's negative log H plus? That is pH. What's negative log OH? That's pOH. So that means pH plus pOH must be equal to 14 at 25 degrees Celsius. Okay, so that's one way of checking kung tama yung solution nyo. Kailangan pag pinag-add mo yung pH pati pOH, it should be equal to 25, it must be equal to 14 at 25 degrees Celsius. Okay? So, ganun. So, dito natin nakuha yung idea na hanggang 14 ang pH scale. No? Because of the ion product of water, the Kw. Okay? So, yun. However, take note, no, ine-emphasize ko yung degrees Celsius. No? This is only true for solutions at 25 degrees Celsius. Bakit? Kasi at other temperature, the Kw changes. No? Just look at this table. Okay, at different temperatures, your Kw starts to change. So that means the product of pH and the sum of pH and the pOH will change. No? Okay, so magbabago yung sum ng pH pati pOH kapag nagbago yung temperature. Okay? So mas mababa yung sum nila kapag mas mataas yung temperature. Mas tataas naman yung sum nila kapag mas mababa yung temperature. Okay? So, ganun lang. That's why we need to emphasize yung 25 degrees Celsius na. Kasi at 25 degrees Celsius, the sum of the two is exactly 14. Okay? So, let's try to answer some basic problems. The pH of rainwater collected in a certain region in the northeastern United States on a particular day was 4.82. What is the H plus concentration of the rainwater? Ito na, nagawa na natin yung ganitong problems sa chapter 1. So ano meron tayo? We have pH. We are going to convert it into H plus concentration. How? Remember, we have pH equals negative log H plus. Ang sabi ko sa inyo last time, pag gusto nyo kunin yung H plus, tatanggalin nyo siya sa logarithm by doing the antilog function. What's the antilog function? Okay, gagawin mo yung numbers na yan na exponent ng 10. Okay, so let's do that. Derive muna natin. So yung negative sign, lipat mo sa kabila. pH equals log H plus. Okay, so at this point, gagawin natin yung antilog. So basically, itong dalawa, gagawin natin siyang exponent ng 10. So we have 10 raised to negative pH equals 10 raised to log ng H plus. What happens is that yung 10 pati yung log, they will cancel out each other, leaving us the concentration of H plus. So matitira na lang concentration ng H plus. So yan, so the concentration of H plus will be equal to 10 raised to negative pH. So ano yung pH natin? 4.82, sabi doon. So you just plug in 4.82. So we solve for the concentration of H plus being equal to 1.51 times 10 raised to negative 5 molar. Okay, so that's the concentration of H plus when the pH is 4.82. Since the concentration of H plus is greater than 1 times 10 raised to negative 7, it means the solution is acidic. No? And also, the pH will tell you na acidic yan kasi lower than 7 yan. So, acidic nga yung rainwater na yan. Okay? So, yan. How about the second problem? The hydroxide ion concentration of a blood sample is 2.5 times 10 raised to negative 7. What's the pH of the blood? Okay. So, paano to? So, there are two ways to solve this. No? Pakita ko yung mga ways to solve it para you have various options. No? Maganda kasi yung alam mo yung mga pwede gawin. Okay, kasi sa limited lang tayo sa isang step. No? Okay, so ano yung unang mong pwede gawin? Okay, so pwede mo gawin from the OH, convert mo siya sa POH, then i-convert mo siya sa pH. Okay, so yung OH to POH, negative log yan. Yung POH to pH, gamitin mo yung pH plus POH equals to 14. Okay? So, gawin natin yan. Okay, so the concentration of OH is 2.5 times 10 raised to negative 7. So, kung kukunin mo yung POH, that's equal to negative log ng OH minus, which is negative log of 2.5 times 10 raised to negative 7. Plug in natin sa calcu. Okay. So that is 6.6. Yan yung POH niya. Paano mo makukuha yung pH? Okay, remember, pH plus POH is equal to 14. So to solve for pH, that is equal to 14 minus POH. So get 14 minus 6.6. That will give us pH equal to 7.4. Okay? So that's one way to solve this. So you start from OH concentration, convert mo siya sa POH, then later on solve for the pH. What's the other way? You can use the KW. Okay? So, given ka ng concentration ng OH, pwede mo makuha yung concentration ng H plus by using the KW. Okay. Remember, KW is the product of H plus and OH minus. If you want to solve for the H plus, you're going to divide your concentration ng OH by the KW. So that will be 2.5 times 10 raised to negative 7 divided by 1 times 10 raised to negative 14. Ano yung concentration ng H plus? Tama ba ako nung solve? Baliktad ako, sorry. Baliktad. Diba? Duling na. Gutom na tayo eh. Okay. So, baliktad yung aking fraction. Okay. So, to solve for the H plus, that will be KW divided by concentration of OH pala. Sorry. Okay, so that's 1 times 10 raised to negative 14 divided by 2.5 times 10 raised to negative 7. We can now solve for the concentration of H plus. Okay, so that's equal to 4 times 10 raised to negative 8. Okay, so since we have the H plus already, we can now solve for the pH. That's negative log of the concentration of H plus. And that's equal to negative log of 4 times 10 raised to negative 8. So we can solve for pH, that's equal to 7.4 then. Okay. 7.39, round off mo na lang, 7.4 din siya. Okay? So, ganun lang. So, yan. Okay? So, ganun lang. There are two ways, no? And both will give you the same answer dapat. Okay? So, ganun. Don't be limited with one equation. Ang dami nating pwedeng kuning relationship dito, no? So, kung wala kang relationship sa math ka maghanap ng relationship, no? Yan, no? Magkakadugtong lang naman yan. So, from OH, POH to pH, may steps. From OH, gawin mong H plus, then gawin mong pH, may another step done. Okay? So, maraming ways, no, to answer this type of problem. Just remember the following relationships, no? So, yan. So, from KW, you can determine this or that, given ito or ayon. And from this, you can solve for this or that, no? Basta given yung isa. Okay? So, ganun lang. Don't be limited with one option. Okay? So, ngayon, punta na tayo sa last part ng discussion natin today. Okay. Hindi natin tatapusin, syempre, lahat, no? Dami pa naman tayong meetings. Okay? So, let's talk about the strengths of acid and bases, no? So, familiar tayo sa words na weak acid, strong acid, no? Paano natin malalaman kung yan ay weak or strong acid? Okay, so ganito lang. There are two types of electrolytes, no? We have the strong electrolyte and the weak electrolytes. When I say strong electrolytes, that means it is 100% dissociated, no? So, ano meaning nun? Lahat ng original amount mo na convert into products. Lahat. Okay? So, 100% dissociation yan. Since we have 100% dissociation, we usually indicate them with a single arrow towards the right. Okay? Single arrow lang, pointing to the right. That means lahat ng amounts nito mapupunta sa product side. So if we have 0.1 molar concentration of Cl minus, pagdating sa product, 0.1 molar din yung concentrations nila. For weak electrolytes, these are solutions that are not completely dissociated. So, ibig sabihin, only portions of its original amount ang madidissociate. So, for example, we have acetic acid. Hindi lahat yan madidissociate into ion. So, onti lang yung magiging acetate ion, onti lang yung magiging H+. Okay? So, that means the solution is not completely dissociated. That's why we use the equilibrium arrow. Okay, so since we have equilibrium arrow, then we can describe this with equilibrium constant. Okay, so ganun lang. So, paano mo malalaman kapag strong yan or weak electrolyte? Ganito. Kapag strong yan, yan ay ionic compound that is composed of metal and non-metal. Except for precipitates, no? Kasi yung precipitate, metal, non-metal din yan, pero hindi siya nagde-dissociate, no? So, yan. So, yan ay metal and metal na hindi precipitate. Yun yung mga strong electrolyte, no? Okay. Or pwede rin namang non-metal, pati non-metal. For example, yung HCl. Okay. So, yun yung mga examples nun. Kapag malaki yung electronegativity difference nila, dun, 100% yung dissociation. Pero kapag tayo ay may weak electrolyte, pwedeng mababa lang yung electronegativity difference or pwedeng may hydrogen bonding kaya hindi agad siya makabaklas, no? Or pwede ring organic molecule yung ating species, no? For example, acetic acid, this is organic molecule. So automatically, weak electrolyte yon. Okay? So yan. So mamaya makikita natin iba pang examples, no? So let's talk about strong acids, no? Strong acids are strong electrolytes, no? Okay. So strong electrolytes yan, all of these are inorganic molecules. So hindi yan organic molecules, no? Kung kukunin mo yung electronegativity difference nila, malaki yan. Okay. So since malaki yung mga electronegativity difference nila, it is 100% dissociated into its products, no? It's H plus and an ion. Kapag weak acids naman, ito yung mga molecules that is not fully dissociated, no? So, pwedeng organic sila, such as yung acetic acid, or pwedeng may strong hydrogen bonding. For example, itong HF. So, yan, malakas yung hydrogen bonding dyan, kaya yan ay weak, no? Okay, so we have this. Makikita nyo, ang gamit natin ay equilibrium arrow. Pag bases naman, ganun din. We have metal, non-metal. In our case, yung non-metal natin ay OH. Okay? So, lahat ng mga to, they will fully dissociate into ions, no? Unless it is a precipitate, no? So, wag precipitate, sa dulo yan ng chapter na to. Saka na natin pag-uusapan yun. Okay? So, yan. Kapag weak bases naman, ayun, usapang hydrogen bonding uli. For example, this one, may hydrogen bonding siya with fluoride ion. So, weak acid yan. Weak base itong equation na to. Okay, so ganun. So, we use the equilibrium arrow. Okay. So, do you have to remember all of this? Kahit hindi naman, no? Kasi pwede nyo naman balik-balikan yung strengths of acid and base using this summary. No? So, pwede nyo i-check dito. Sino yung strong acid, sino yung strong base. Okay lang yan. No? So, remember that kapag yan ay weak acid or weak base, we use the equilibrium arrow. Pero kapag yan ay strong, we use the single arrow pointing to the right. Okay? So, ganun lang. So, let's talk about the conjugate acid pair. The conjugate acid base pair kapag may strong acid, strong base tayo. And sabi dito, the conjugate base of a strong acid has no measurable strength. So, ibig sabihin, kapag strong acid yan, yung conjugate base niya, hindi nagmamatter yung amounts niya. Okay. So, ganun. Bakit? Kasi full yung dissociation na. Then also, H3O plus is the strongest acid in a solution. And OH is the strongest base that can exist in basic solutions. Okay? So, ganun lang. So, ito naman, this shows us the ionization of strong acid and weak acid, for example. So, kunwari, tignan nyo. Pag strong acid yan, we have HCl lahat. Pagdating sa product side, ang na-produce ay H plus and yung Cl minus. Virtually, wala tayong HCl. Kasi sabi nga natin, full dissociation yan. So, lahat ng HCl mako-convert into ions. Yun ay kapag strong acid. Pero kapag yan ay weak acid, tignan nyo. So, kapag HF, weak acid yan. Pagdating sa product side, we still have lots of HF and few amounts of the products, the H plus and the F minus. Okay? So, yun yung difference. Kapag strong acid, full yung dissociation. Pag weak acid, hindi full yung dissociation. Since hindi full yung dissociation niya into the products, we can describe them by equilibrium equations. Okay? So, ganun. So, ganun ha. Pagdating sa strong acid, wala nang equilibrium dito kasi lahat magiging products. Stoichiometry na lang yung solving dyan. Pagdating sa weak acids, ito na yung gagamit ng equilibrium. No? Bakit? Kasi uneven yung amounts nila. Uneven yung distribution ng reactant pati product. So, gagamit tayo ng equilibrium system dyan. Okay, so let's try to answer some problems. Number 1, we have pH equal to 2 times 10. Hindi. Ano pala? What is the pH of a solution of 2 times 10 raised to negative 3 molar HNO3 solution? Remember, nitric acid is a strong acid. No? So if you want to get the pH of nitric acid, which is a strong acid, yan na, strong acid siya. So if you want to determine the pH of that acid, ang kailangan mo lang gawin is ganito. You write down the equation. HNO3, it will produce H plus and NO3 minus. So since HNO3 is 2 times 10 raised to negative 3 molar, by stoichiometry, H plus is 2 times 10 raised to negative 3 molar then, and NO3 minus is 2 times 10 raised to negative 3 molar. Okay? So kung ano yung concentration nito, yun din yung concentration ng products. Okay? What if may 2 dito? Kunwari may 2 dyan. The times 2 mo yun. Okay? So ganun. So yan, by stoichiometry lang yung solving for the concentration of H plus. Okay? Ayan. So since we already know the concentration of H plus by stoichiometry, then we can solve for pH. That's negative log of 2 times 10 raised to negative 3. So ang pH niya ay 2.69 or 2.7 yung pH ng solution na yan. Okay? So ganun lang. Again, kapag strong acid, yung pagkuha ng pH, direct na. Okay? Alamin mo lang yung concentration ng H plus by stoichiometry. Okay? So kapag 1:1 lang yan, edi yan. You can directly solve for it. Punta naman tayo dito sa next one. What is the pH of a 1.8 times 10 raised to negative 2 molar barium hydroxide solution? Barium hydroxide is a strong base. Okay? Strong base yan. Nandito yung example natin dyan. Yan. So, barium hydroxide is a strong base. Okay? So, that means it will fully dissociate into ions. So, let us write the equation. So, yan. When barium hydroxide fully dissociate into ions, it will produce 1 mole of barium ion and 2 moles of hydroxide ion. Okay, so let's determine the total concentration of OH by stoichiometry. Okay, so if we have 1.8 times 10 raised to negative 2 molar of this, stoichiometrically, barium ion concentration is 1.8 times 10 raised to negative 2 molar. How about the OH minus? Ano yung total concentration niya? Okay, so since we have a coefficient equal to 2, then we have to multiply the original concentration by 2. Okay? So, i-multiply natin siya. Ita times 2 natin yan. Paano naging ganon? Okay. So, pakita ko sa inyo yung stoichiometry, no? So, if you have moles ng barium hydroxide, di ba, pag i-convert mo siya sa OH, you use stoic, no? Ano yung stoic nila? Factor. 1 dito, 2 sa taas. So, basically, yung moles ng barium hydroxide, ito times 2 mo. Yung mole, pwede natin gawing molarity din yan. No? You just divide it by the volume. So that means if you want to get the molarity of OH minus, you just use the same formula sa conversion from this to that, no? From barium hydroxide to hydroxide. No? You have to use the same formula lang din. Okay. So that means ita times 2 mo pa rin yung OH, no? To get its final concentration. So stoic lang. Okay, so that means the concentration of OH minus in the solution is times 2. No? Teka lang, 1.8 times 10 times 2. So that will be 0.036 molar. Okay? Magta times 2 lang din yung concentration niya because of the coefficients. And since we know the concentration of OH, we can solve for the POH first. Okay? This is the negative log of the concentration of OH. Okay, so that's 1.44 for the POH. Then to solve for pH, that's 14 minus POH. It will give us 12.56 now. So this is the pH of the barium hydroxide solution. Okay, so again, kapag strong acid, strong base, the amounts of H plus and the OH can be directly obtained using stoichiometry. Okay, so stoic lang sila. Paano ko sir malalaman kapag strong acid, strong base yan? O you have your kodigo na dito. May kodigo na kaya yan, no? Yan, nakalista na kung sino yung strong acid and ano yung corresponding equation nila. Okay? So yan. You can use this naman. Pwede ilista nyo yan. Okay? Huwag nyo na kabisaduhin syempre. Although over time, makakabisado nyo rin yan. Okay? Pero pag hindi pa kabisado, di okay lang. Lista nyo na lang sa notes nyo yan. Okay? So again, the concentration of H plus and the concentration of OH for strong acid and strong bases can be obtained directly using stoichiometry. What if weak acid yan or weak base? Then we have to utilize the equilibrium constant. Okay? Kailangan mo gumamit ng equilibrium constant na. Suppose we have a weak acid HA. When it dissociates into ions, it produces H plus and the anion A minus na. Yung HA na yan, dummy chemical formula. Yung A, pwede mapalitan niya ng acetate ion, fluoride ion, etc. Okay. So, we usually tell HA as the weak acid kasi, no? So, suppose we have this dummy equation HA. When it dissociates, it produces H plus and A minus. If you get the equilibrium constant for this one, ito yung makukuha natin. And since the equilibrium constant is acidic, we call it the Ka. Ka yung tawag kapag equilibrium constant ng acid. Ka. So, marami na tayong versions ng K, no? We have the Kc, equilibrium constant in terms of concentration. We have the Kp, equilibrium constant in terms of pressure. We have the Kw, that's the equilibrium constant in terms of water ionization. And we have the Ka, which is the equilibrium constant for acids. No? So, yan. So, ito yung Ka ng ating acid. No? So, if you want to determine the concentration of H+, then you have to do algebra calculations. Katulad ng ginagawa nyo sa lecture sa previous chapter. Hopefully, tapos na kayo dun. No? Okay? So, i-discuss natin yun dito. Then, okay? So, ito yung mga Ka ng weak acids, no? And the Kb of their conjugate bases. So, saka na natin pag-usapan yung conjugate base. So, anyway, ito yung Ka nila. Okay? So, we will use this table to check kung ano yung Ka values kasi hindi naman yung kinakabisado, no? So, yan. You can save this photo as well, no? It will be helpful pag kayo ay magku-quiz or mag-exam. Okay? So, save nyo lang yan. So, yan yung Ka values natin. Kapag bases naman, ito yung ionization ng base, no? Weak base. So, this is one example. And so, kapag nag-ionize yan, it will produce these products, no? If you want to get the equilibrium expression for the base dissociation, that is called the Kb. Now, Ka kapag acid, kapag base, Kb. Okay, so ito yung itsura ng example na to. Okay? So, yan. Hopefully, marunong naman kayo na magsulat ng equilibrium constant. And these are the corresponding Kb values for the different bases here. Okay? So, wag nyo kabasaduhin yan. Tinitignan lang yan. No? Nililista lang yan talaga. Okay. So, ngayon, kunwari, tanong, determine or calculate for the equilibrium concentration of H+. Ano ginagawa natin? Gagamit tayo ng ice table, di ba? Na-discuss na yan for sure. So, ano yung ice table? It will tell us the changes sa concentration as the system tries to achieve equilibrium. Okay? So, identify mo muna yung mga species that could affect the pH, then you construct your ice table. Yung change, ginagawa mong X, no? Kasi hindi mo alam how much the concentration of the substance will change. So, we place the unknown variable X. Then, later on, we solve for the value of X, either using algebra or calculator. So, may video akong in-upload doon last time sa aking channel na yung calculator technique, siguro naman napansin nyo yun, no? Especially kapag naka-bell notif kayo. So, yung calculator technique, pwede panoorin nyo na rin yun, no? Especially kapag may quadratic equation sa ating calculation. No? Magbibigay ako example. Okay. Then, once na makuha mo na yung value ng X, you can now calculate for the equilibrium concentration of your species. Okay? So, this has the same approach doon sa inyong lecture lang din. Okay? Kung paano kayo mag-solve ng equilibrium concentration sa lecture, ganito lang din dito. Okay? However, may technique pa akong ikukwento sa inyo. Okay? So, saka na yan. Sa susunod na meeting na lang yung technique. Sa ngayon, answer muna tayo ng basic problem. Then after this, we will cut our session. Next meeting na lang yung technique. Okay? Kwento ko na lang yung technique sa susunod na pagkikita natin. Okay. So, ito. Let's calculate for the equilibrium H plus concentration of 1.2 molar nitrous acid. Okay. Kung ito ay HCl, kunwari HCl yan, what's the concentration of H plus? Pag yan ay HCl, 1.2 na rin. Kasi we know HCl is a strong acid. So whatever the concentration of the acid is, that's equal to the concentration of H+. So 1.2 na rin sana. Pero nitrous acid to eh. And nitrous acid is a weak acid. Okay. Nandun yun sa nakalista kanina. Weak acid yan, yung HNO2. So that means we cannot directly solve for the H plus concentration. We have to do something else, no? Para makuha mo yung H plus concentration niya. O, hindi siya agad-agad na 1.2. Kasi weak acid yan eh. So, it is less than 1.2. Then, for us to solve for the exact concentration of H plus, we have to use the ice table. Or some may call it the rice table because on the first row, you have to write the reaction. Kaya rice table siya sa ibang reference. Pero ako, nasanay ako ice table na lang. No? So, let's construct the ice table for this equation. Okay. Alam ko marunong na kayo, no? Pero sabayan nyo pa rin ako. So, ano gagawin natin? Sa ice table, wag mo isusulat yung liquid pati solid. Hindi siya isusulat. Okay. Only those who are in aqueous or gaseous phase ang isusulat. So, we have HNO2. Then it will dissociate into H plus or H3O plus and then nitrite ion rather. Okay. So we have HNO2, it will dissociate into hydronium ion and nitrite ion. So yung mga liquid, wag mo na isama kasi hindi mo naman siya isusulat sa equilibrium constant. Okay. So then let's take another look sa problem. The initial concentration of nitrous acid is given as 1.20 molar. So that means itong initial concentration na to ay 1.20. How about the others? Walang sinabi. So kapag walang sinabi, 0 yan. Okay? So kapag walang sinabi, 0. Kung ano lang yung sinabi sa problem, yun lang ilalagay mong concentration. Okay? So, yan yung initial concentration natin. We have 1.2 of nitrous acid, 0 for H+, and 0 for NO2-. How about the change? No? So sabi ng inyong lecture dito, we introduce unknown variable x. No? So ano yung unknown variable x natin? That corresponds to the change in concentration. However, the x could either be positive or negative. Paano mo malalaman kung yan ay positive o negative? By comparing the reaction quotient with the equilibrium constant. No? So kung yung Q mo ay less than the K, then the reaction is going to the product side. Kapag Q is greater than K, ay sabi ko dapat kanina is Q is less than K, no? The reaction is going to product. But if your Q is greater than K, the reaction is going to the reactant. So depending on where your reaction is going, the sign for the change could either be positive or negative, no? Okay. So, kunwari, kukunin mo yung Q neto, yung reaction quotient niyan. What's the expression for the reaction quotient? That's the concentration of hydronium ion initially, concentration of nitrate ion initially, divided by the concentration of nitrous acid. So what's the concentration of H3O initially? Wala. What's the concentration of NO2 minus initially? Wala din. What's the concentration of HNO2? 1.2 molar. So saan yan equal? 0. Since we know that Q is less than the K, ito yung K natin. Okay? So since Q is less than the K, then the reaction is going to the right. Okay? So the reaction is going to the right or towards the product. So ibig sabihin nun, for the change, yung product madadagdagan, yung reactant mababawasan. Okay? So ganun yun. If the reaction is going to the right, then yung product madadagdagan, yung reactant mababawasan. Okay, so that means the change for nitrous acid is negative X. The change for the products will be positive X. Okay? So yun yung isang way to tell kung paano mo malalaman yung direction ng reaction. You compare Q and K. Okay? Ginagawa nyo naman yun sa lecture for sure. Okay? Another way to determine yung direction ng reaction is ganito. Ito yung shortcut natin. Kung nasaan yung zero, doon papunta yung reaction. Okay? So kung nasaan yung zero, doon papunta yung reaction. For example, nasa product side yung zero, edi doon pupunta yung reaction. Pag nasa left side yung zero, edi doon papunta yung reaction. Okay? Kapag nasa right side yung zero, positive X sa product side, negative X sa reactant side. Kunwari, ito zero, given to. Kunwari, ito yung zero, ito yung magiging positive, ito yung mga negative. Okay? So, ganun. Kung nasaan ng zero, doon pupunta yung reaction. Also, if may coefficient ka, kunwari may 2 ka dito, ilalagay mo yun dito sa change. Maging positive 2x yan. Because we follow the law of conservation of mass. Okay? So, we still follow the stoichiometry here. So, kung may 2 na coefficient dyan, you have to place positive 2x. No? Just to, observe the law of conservation of mass. Okay? So, we follow stoic pa rin. Ang pagdating ng equilibrium, ano ginagawa nyo? This plus this, di ba? Pinagsasama nyo. I plus C, you get the E. So that's 1.20 minus X. Then for H3O, that's 0 plus X. X lang yan. HNO2 plus X, that's also X. No? And then ano sunod na ginagawa natin? We solve for the value of X. So we construct the K first. You write K. Okay, for the reaction, K can be given as the concentration of H3O plus times the concentration of NO2 minus. Then sa baba, sa denominator, we write the concentration of nitrous acid. Tapos anong ginagawa dyan? You plug in the numbers. No? So yung K natin, that's 7.1 times 10 raised to negative 14. For the numerator, concentration of H3O is X. Concentration of NO2 is also X. Then sa baba, we have HNO2 that is 1.2 minus X. Okay. Then, quadratic equation na. Right? So, let's simplify this. So, we have 7.1 times 10 raised to negative 4. Negative 14 ba? Negative 4 yan. Okay. So, this is typo. So, that will be equal to x squared. 1.2 minus x. Okay. Then, we cross multiply. So, we will get x squared equals 7.1 times 10 raised to 4 times 1.2 minus x. Okay. So, nag-cross multiply lang ako dito. And let me zoom in dito. So, yan. Cross multiply ko ito para mapunta doon. So, we have this expression. Then, we simplify this algebraically. Ito, gagawin ko na lang para kayo na bahala recalculate later. Okay. Hopefully, mabilis na kayo sa algebra this time. So, yan. So, we get x squared equals 7.1 times 10 raised to 4, negative 4, times 1.2. That's equal to 8.52 times 10 raised to negative 4 minus 7.1 times 10 raised to negative 4x. And then, ano susunod na gagawin natin? We pattern it with the quadratic equation. We have the ax squared plus bx plus c equal 0. So, ipapattern natin to sa quadratic equation. So, this equation can be written as x squared plus 7.1 times 10 raised to negative 4x minus 8.52 times 10 raised to negative 4 equal 0. So, ipapattern mo siya. Then, what's next? You identify coefficient ng x squared, x pati ng number lang. Or you identify a, b, and c. So, what's the coefficient of x squared? 1 lang yan. What's the coefficient of x? Yun yung letter B, which is positive 7.1 times 10 raised to negative 4. And what's the value of c? Yung number lang. That's negative 8.52 times 10 raised to negative 4. Tapos ano susunod na gagawin nyo dyan? Quadratic equation. Quadratic equation is x equals negative b plus minus square root b squared minus 4ac over 2a. You plug in the values of a, b, and c sa quadratic equation. Or, you can just use my shortcut, yung calculator technique. So, if you haven't watched the video yet, panoorin nyo na lang. Kasi, yun yung gagawin ko, calculator technique. Okay? So, ito-type ko na lang to sa calculator, ha? Ilalagay ko yung A, yung B, and yung C sa calcu. So, para makuha ko yung X values ko. Okay? So, kapag hindi kaya ng calculator nyo yung technique na tinuro ko dun sa video na yun, you have to do this manually. Gagawin nyo yan manually. It will take you time to do that. Okay? So, the A is 1. B is 7.1 times 10 raised to negative 4. C is negative 8.52 times 10 raised to negative 4. So I will get the x value equal to 0.03 molar. And the other x value is negative 0.03. Okay? So bakit dalawa yung x value ko? Dalawa yung roots ko. Bakit? Kasi look at the quadratic equation. Yung isa positive, yung isa negative. So, isosolve mo muna yung plus, then isosolve mo yung minus sign naman. Kaya dalawa yung x values mo. Because according to algebra, the exponent for the polynomial will tell you how many roots are there in your polynomial or how many solutions are there in your polynomial. Di ba? Math yan. Hopefully, naalala nyo pa yung math nyo. Kung ano yung highest degree ng polynomial, that is the number of solutions sa polynomial. Kunwari, x raised to 5 yan, edi 5 yung x values natin. X square yan, edi 2 yung x values natin. X cube yan, edi 3 yung x value natin. Okay, so we have two x values now. We have positive 0.03 and negative 0.03. Alin sa dalawa ang gagamitin? Alin sa dalawa yung ilalagay ko dito sa ice table? Yung positive yung value. Okay? So kapag may negative value ka, please discard it. Hindi mo gagamitin yan. You discard the negative x values. No? Okay? We only choose the x value that is positive. Ito naman, question. What if parehas silang positive, sir? What if parehas silang positive? Then ito yung gagawin mo. Pag parehas silang positive, you will choose the x value that is less than the initial concentration. O kunwari ito, 1.2. Tapos ang nakuha mo na x doon, 2. Huwag mo gagamitin yon. Kasi when you subtract it dito, pag nilagay mo yung x value na 2 dito, maging negative yung concentration ng HNO2. Again, walang negative na concentration. Walang may utang. Okay? So, ano lang yan? Positive lang dapat yung concentration. So, again, kapag parehas silang positive, you only choose the x value that is less than your initial concentration. Kasi kapag greater than the initial concentration nilagay mo dito, may negative yung equilibrium concentration niya, which is wrong. Okay? So, wrong yun. Pag ganun. We only choose the positive x value and less than the initial concentration dapat siya. Okay? So, yun. So, we know that x is positive 0.3. So, we can now plug it here sa ating ice table. X is 0.3, so that means H3O plus concentration is 0.03 molar. NO2 minus concentration is 0.03 molar. And the concentration of HNO2 at equilibrium will be, calculate ko. That's 1.2 minus 0.03. Kanyang equilibrium concentration na lang ay 0. Sorry, hindi siya 0. That will be 1.17 molar na lang. Okay? So, ganun lang. So, ganun lang yung solving. So, again, mapapansin nyo that yung ating H plus concentration for weak acid, that cannot be solved directly. Hindi siya agad-agad masosolve. Kasi kapag strong acid, dali lang, di ba? Katulad ng example natin dito. Stoic lang yung ginawa natin to get the concentration of the H+. Pero kapag yan ay weak acid, weak base, you have to do the ice table. Okay? So you construct your ice table, you plug it into your equilibrium expression, and then you do algebra stuff, and then you get the equilibrium concentration. Okay, so mapapansin mo yung H plus concentration mo, that's less than the initial concentration. Bakit? Kasi nga, partially dissociated lang itong nitrous acid. So, onting portion lang niya yung magiging H plus. Okay? So, that's the reason why H plus concentration is less than this. Ano kaya yung pH ng solution na to? So, the pH can be obtained from the equilibrium concentration of H+. So, kung ano yung equilibrium concentration ng H+, dun mo pwede makuha yung pH. Okay? So, that's negative log of 0.03 molar. So, ano yung pH ng solution natin? The pH is 1.52. So, ganun. Compare nyo yan sa strong acid. Tingnan nyo, sa strong acid, kung ano yung H+, yun na yun. Kung ano yung concentration ng acid mo, yun na yun, di ba? Pagdating dito, hindi. Mag-ice table ka muna. Yung 1.2, hindi yun yung ipa-plug in mo dito. So, solve mo muna kung ano yung equilibrium concentration ng H. Okay? So, ganun. kapag stable. Okay? So for next meeting, we will continue on this one kasi gutom na rin ako katulad nyo. Okay? So for next meeting, we will continue again. However, I will tell you a shortcut. Ito yung shortcut na yun. Tawag ko dito ay Chaka. Okay? Kasi you can get the you can get the concentration of H plus by getting the square root of Chaka. Literal na Chaka. CHA, that's the concentration of acid. Ka is the acid dissociation constant. So pag-usapan natin yung mga Chaka sa susunod na sa susunod na meeting, okay? Bakit? Kasi itong square root of Chaka na to, yun yung magpapadali ng ating buhay. Hindi na natin kailangan gawin tong sandamukal na bagay na to. Okay? So next meeting, pag-usapan natin yung mga Chaka, and then we will continue with other examples ng acid-base, equilibrium, percent ionization, and then pag-usapan natin yung diprotic, triprotic acid, and buffer solution. Okay? So I'll see you again next meeting. Again, kung gusto nyo mag-review ng equilibrium constant lecture, may video ako ng lecture. Ang title niya ay may section 1, section 13, or section 14 na nakalagay. Okay? So kung gusto nyo manood ng lecture ko, section 1, section 13, section 15 yung nakasulat na title. Okay? Kung gusto nyo panoorin yung video about the calculator video, panoorin nyo na lang. Nandun lang din yun sa playlist natin. Nakalagay MTY1103 calculator technique. No? So, ganun. Ayan. So, hopefully by next meeting, napanood nyo na yung mga ganung videos na para tuloy-tuloy tayo sa pag-solve na. However, if yung calculator nyo, hindi talaga kaya mag-quadratic, pwede gumamit na lang kayo ng website. No? Ito-tell ko sa inyo kung anong website yung gamit ko pag tinatamad ako mag-calcu. Okay lang din naman. Pwede nyo naman gamitin din to. Basta tama yung plugin nyo, ha? I use Symbolab. Okay. Symbolab is a website that helped me during my undergrad. Siyempre, kapag wala akong calcu, nagsisimbolab ako. No? So, this can solve for the value of x. No? Hindi mo ilalagay yung buong problem dito, siyempre. Yung quadratic equation lang. Kunwari, ano yung quadratic equation natin kanina? We have 7.1 times 10. Ay, hindi ko na to type. Plug in ko dito yung equilibrium expression. 7.1 times 10. 10 raised to negative 4. Ay. That's equal to, ano yung nasa numerator natin kanina? X square. Then yung nasa denominator ay 1.2 minus x. Pwede ito na yung mag-solve ng value ng x. Ayan. Papakita nyo sa yung x values. Which are, ayan. Which are 0.03 and negative 0.03. Okay, so pwedeng ganito na lang gamitin nyo. Pero again, better pa rin if you know the calculator technique. Kasi pag nag-exam kayo, kunwari board exam, calculator talaga gamit nyo. May ganyan ba sa boards? Wala naman. Pero still, mas maganda masanay tayo sa calculator. Okay. Yung calculator natin, ito yung bubuhay sa atin hanggang dulo. For example, itong calcu ko, gamit ko to since 2014. Nag-start ako college 2014. Until now, magkasama pa rin kami. Okay. So, ganun. So, mahalin yung calculator nyo, ha? Okay. So, ganun lang. So, again, I'll see you again next meeting. Kapag hindi kaya ng calcu, gumamit ng Symbolab. No? Pero wag masanay mag-Symbolab. Mamaya hindi nyo na ginawa talaga yung quadratic equation. No? Better pa rin na alam nyo yung basics before you go with the shortcuts. Okay? So, I'll see you again next meeting. No? So, kain na po tayo ng lunch. No? A copy of the video will be uploaded tonight. No? So, bye-bye and see you again. Okay.